All right, let's go ahead and get started with this the stream and the video. To those on my Twitch stream, thank you for joining us. I really appreciate it. It's been a blast so far. To those on the YouTubes, thanks for checking out this video. We really appreciate it. Right now we're 46 episodes into this series, and it doesn't really look like there's going to be an end in sight anytime soon. We still have a lot of ground to cover, a lot of things to do, and some catch up to do. And that's what we're going to be doing today, is a little bit of catch up. Mainly because I don't want to let things get too far behind on some of the administrative side, which, yes, does include documentation and some changes, some updates to the design based off of our testing and our rework yesterday, successfully fixing the UART to USB bridge chip on the pilot board. But it's a very big positive, so we're definitely moving in the right direction. That's just led me to believe that we're just going to go ahead and change to a different chip, because I don't want to risk sticking with the one that was on there that we replaced for the other variant, just in case there are problems with it. We're just going to stick with a tried and true IC that we know works, and I don't want any problems with it. The one we're going to go switch to is a little bit more expensive, but it's fine. Again, it's more feature rich, and again, I've had no problems with it. And those who tuned in and will be checking out this video on YouTube when it drops will see that it actually worked, even after doing a hot air rework to it. So, if you like what we're doing, definitely like and subscribe. Hit that bell notification to be informed of any new videos. I know a lot of people who view and stuff don't like being told to subscribe or being like we're begging you. But unfortunately, the algorithms are the algorithms. That's what we're fighting. We're fighting, I'm wanting my channel to grow, to get this information out there. And I'm fighting hundreds, thousands, millions of other YouTube channels. And unfortunately, I have to ask. I have to beg. It's just, unfortunately, when you deal with mathematical algorithms that decide your fate, you've got to plead your case so the viewer knows. And then the viewer's decisions affect how the algorithm works moving forward for other viewers. It's crazy. It's just a continuous content stream, and there's just a lot of competition. And I believe in what we're doing with getting this information out there, this knowledge, and so, I'm going to keep asking for it. I apologize if it's a turnoff, but unfortunately, that's just the way the world has to work until we do things differently. So, the first thing I want to do before we get too far involved is catch up on some of the administrative stuff with Odo, with our ERP solution, because we still have these manufacturing orders sitting here. Which means the system hasn't consumed any parts. It doesn't believe we're, doing anything. And I should have turned Steam off, but hey, that's fine. So we have the status here saying available. So for the fan with JST 4-circuit plug, that's the fan assembly that we built. Used on the stream and in the video. We built it. We tested it. So right here, we're one to produce. We're going to produce all. And then what that does is it just goes ahead and consumes the inventory. That way, we know that the materials are used in inventory. And then what this should do then is, let's see, open link and do tab, products. I like doing this one, assembly level goods. So now it should show we have one fan assembly in stock, basically. So that's also what it'll do. It'll consume the connectors. So it'll consume, one of these guys. So we had 10 in stock because we ordered 10. Now it consumed one. So that's what it'll do is it'll consume our inventory, so we can better keep track of our inventory and have our stock. So back to manufacturing orders, not dropped off. Now we have the SMT level for the PCB, which we did. We're going to be 1. We're going to produce all. Boom. So that was done. Back to manufacturing orders. So what that's going to do then is SMT level. And then what's funny, it's going to show 1 in stock. So in the long run, just to kind of throw this out there, so in the long run, when you're in the in like say the production phase, you're actually putting these on the market, you're more than likely going to have the boards panelized. So you're kind of a matrix setup of like, you know, like kind of like a board down here, a board. I know it's hard to see, but like in an array. So you're going to have more than one board being pick and place assembled through the SMT line at a time. So sometimes you'll have like, a quantity of SMT level boards on hand, like say 10. Let's say you've got an array of like 10 boards. Let's just say that, throw that out there. So you've got 10 on hand, but you only need like assembly level like 5. So, you'll all your manufacturing orders and stuff. So that's another reason you want to do this. So now notice that since it pushed a PCB SMT level, now it's available. Because now we have the SMT level. That's why we do all this. Now it's time to consume all of the through hole parts. We're going to produce. There's only 1. Boom. So there we go. So that produced all of our manufacturing orders. And now the PCB assembly dropped down to 0. SMT level assembly. I think I need to refresh this. Probably need to refresh this. So yeah. So PCB assembly level. And so the fan assembly got consumed because now it's part of this PCB assembly. Yeah, I did just refresh it. And the SMT assembly got consumed and is now part of this PCB assembly. So that's why you do this, to keep track of your individual phases of your products, because again, this fan could be an inventory item. This fan assembly is something that you could sell as like a replacement or an upgrade or something, or you can sell like a basic version of the board without the fan, and you can sell like a deluxe version as the fan and the 3D printed enclosure. Who knows? I might do that with this product. I'm not sure, but this gives me options. And then the SMT level, again, is to keep track, because if I have panelized boards, that will know of, oh, hey, I've got 5 already built. I can just do the through-hole work on 5 additional. So that's why we're doing this. And it consumes all the individual parts. So when we go to throw in another manufacturing order, it'll say, oh, you're missing parts. That way I know I need to order stuff. So it does with like planning and preparation. So you want to keep this as in line as possible. And with that in mind, even though I'm not going to... Okay, I see. So, even though I'm not going to use these anymore, I still want it to actively keep proper inventory. So there's 4 in hand, and I think... Scrap. So we're going to scrap 1. Scrap 1. I should have copied that. Good thing we don't have a whole lot in here. Interface ID, I see your, so there's only 1, so we're going to click on that. We're going to scrap 1. Scrap location, inventory adjustment. Source document would be, we could kind of create a process when you have to scrap, but since we had to pull one out to try reworking, we just got to scrap it. Scrap reason, rework failure. Okay, failure. There. Well, wait a minute. Rework failure. So we're going to validate. So what that does, it'll take 1 out of inventory. and we have a record. So you definitely, that's another reason you use an ERP system like this, is to just keep track of everything, because, you know, in the long run, you'll have to, especially if you start having to pay tax. You hit that point where you're going to be paying taxes. So now the IC should, well, let's see. So now it's only showing 3 on hand. So we bought 5. We consumed 1 through the manufacturing process, and then we had to scrap 1. So we have 3 left. Now, because of the decision to change that chip out, we've got to do some stuff in Odo. So I've already gotten the... Good thing is, it's a... pretty much it's a footprint pin for pin drop-in part. As we've shown, this is just, like I said, the big brother of it. So what we're going to need to do is, so let's first get my stuff, let's get everything all sussed out. I don't know why I just did that, but that's fine. I'll deal with it here in a minute. So we have the part number. You know what? I don't know why I didn't just do this in the first place. Let's drag it over here to the tabs. All right. So again, it's just got a slightly different part number. So what we're going to do is, let's see here. Can I duplicate? Duplicate. I can. I don't want to duplicate it. Okay, so I have a copy. So let's go ahead and copy this. Go here. Okay, 802 purchase by quantity on hand. Okay, that's good. Cost is $352, so it's actually a little cheaper than the other version, which is IC. So I'm gonna grab this. All right. So what's going to do? It's going to complain that the references are the same. That's fine. So we need to find something different. 4085. We need to kind of differentiate it from, yeah. It's going to be mad because it already exists, because for some reason it wants to look at the reference rather than like the product ID. That's what it wants to complain about. So let's see here. Interface IC, USB. Oh, let's kind of USB 2 full speed. Yeah, so that's what we'll do. We'll just kind of give it a slightly different wording. Purchase Mausa, and we're going to grab their product code. So this is probably one of the easier products to add in here. We're going to save that. So administrative, so let's get that close. We don't need it in the way. So this we can close for now. Just get it out of the way because I could use it for something else. Just in case I need a reference back to Mauser for anything. So what we need to do is kind of take a bunch of different things and deal with them accordingly. So we have our design. So this is the circuit, but what we need to do is we need to create the library entries for this. And fortunately, what we can do is under components, we have the part. I'm going to go ahead and go back to this guy, grab this part number, components, and we're going to duplicate. Oh, file, properties. Okay. All right. I think I gotta rename 802. Okay. Save it now. That's what I do. Files and properties. 802. It's got to have the same footprint. So let's go over to here. Grab this guy. Okay. So we know its manufacturing part number is this. Get the Mauser part number. And it's 352. Low volume and no, I have to go back over here to the other window, see what the high volume is. Probably roughly the same. 1,213. No, high volume is a little bit higher. All right. 802 QFR has the same footprint, but what we need to do now is we're going to save it. So we need to assign these pins because a lot of these pins now have totally different functions. So I'm going to pull up the data sheet for it. And I'm just going to bring us to the pin out. It's a QFN 28. All right. Yeah, so we have GPIO pins now. And then here are the LED toggles. So what we need to do then is I'm just going to move off to the side and we're going to go through and see what changed. All these guys are the same. Pin 10. No connect. Pin 13. GRAN. Okay, so we have to change that to passive. Pin 14, CH1. 1. Pin 15. And passive. Pin 16. So I'm just going to go through all these and GPIO 3. So this one is one of the pins that you can control this and use it for RS-485 and not just standard RS-232. One RXT. So that's for the LED the receive LED. Pin number 19. It's got a couple of GPIO pins that can be assigned to different things. I've never really used them for anything, but it can be. Again, 22. 4. All right. So just make sure 23 and 24. CTS and RTS, yeah. 25, 26. To make sure, yep. I mean, I know they work because, like I said, it's a pin for pin. 728, yep. Center pad is ground, boom. So what that does is now all of a sudden, bang, we've got our new pin mapping. And if we really wanted to, we could use these additional pins in the project, but we're not going to worry about it for this project, but we now have the opportunity. And like I said, it's a drop in pin for pin and footprint chip to the one we're already using. So I am not terribly worried. So what we're going to do then is I'm going to close this because we don't need the library anymore. Minimize this. All right. So it's going to be IC5. So components. UPC QFN28R. Boom. We're going to actually, let's see if I can. Let's see if we can change this guy. I'd rather do that. Change symbol. No, I'm going to replace. Is there a replace? What is this change symbol? Change IC5. Change selected symbol. Oh. Oh, maybe this is what I have to do? Okay, perfect. Okay, so yeah, like I said, I'm learning KiCad. I didn't know I could do that. Ultium and Circuit Studio make it just as easy. So all that, everything else will stay the same. Thankfully, it's not something we have to worry about. Let us add the no connect on these additional circuits because we're not going to use them for this project. Down the road, we might change. We could always add LEDs to the RX and TX, and we can use the Simplicity Studio once I figure out why it was kind of bondungled and program it. Who knows? Maybe down the road, maybe later as we do some more testing, we'll want to. But again, this is just for the USB UART for flashing the ESP32. I mean, we could even throw in another one of these. Basically reproduce this circuit with another USB port, another one of these chips, basically for debug UART, and still have the FTDI plugin header. It would still be usable. Basically, you could use either or. Who knows? Down the road, we may change our mind and add that to this board. But right now, we're going to keep it the way it is and do some more testing with it. So one of the other things I want to do is... So, where did I... preferences? No. View. No, that's right. This does not have. I'll have to look more into it, but I'd like to be able to have like a universal. So in Circuit Studios and Altium, Circuit Studio and Altium Designer, I could create, design templates and stuff to where I could just enter a parameter and it would change all the information on the in the title block and everything, like current revision and stuff. Because technically, I should have like text in there showing Rev 2. So text. 2.0. Actually, Rev 2. I forget. There. Let's see here. Yep. Okay, that's fine. Power supply. Then they change all these at the same time. Because technically the whole you're versioning the design as a whole, and we should be revising this. Make sure we have a revision. Yeah, the parameter makes life easier. I'll have to dig more into AutoCAD to see if it'll let us, or KiCad to let us do that. But I'll have to dig into that. We'll have to figure that out. And then it'd be consistent across the entire board. So we've got the USB UART chip changed here. Technically, we don't have to change anything on the PCB, but I do like updating things for the next order, because I'm thinking since we are changing things and eventually we're probably going to be buying more PCBs, let us get in there and rev the board. All right, rev the board, because I'm thinking we're going to go and throw some more test points. We have some room, physical room here, so we can grab hold of some of the stepper signals. The outputs we can do through the terminal block, but I'm thinking like the drives, the enables, and everything. I want to throw some more test points on here. We'll do that later because I want to focus on kind of getting a little bit of a roll going with this. What some of our next steps should be. So we're going to copy this name and we're going to create a new folder. And we're going to rev that project outputs. So preferences, I think. Try to remember where I can set all the what's that up? All the outputs. Only had to do it once in here. Now I can't remember where to do it at. Preferences, tools. Oh, you're gonna drive me nuts, aren't you? Edit. I want to create the outputs. It's not in the board setup. It's got to be in the project setup. All right. Preferences. Tools. Oh, configure paths. Nope. Oh, wait a minute. What? Huh. Maybe we'll have to figure out how to do that. set in default paths. Maybe here, preferences. I'm not going to waste too much time. Because I want to be able to configure where it dumps the files. I can't remember where I did that, the outputs. We will figure that out before we have to re-export, because I don't expect to do any KiCad exports right now. But while we're here, so let's go into here. We're not going to reprint. Jeez. Catch that, fix that. Okay. We're going to copy the bomb. Put it here. We're going to go and rename it. Version 2. And then we're going to open with LibreOffice. I could open it in Excel, but all right. And unhide. Show columns. Boop. All right. Now, so what we're changing is the one I see. It's got the same designator, so we're not going to shoot ourselves in the face trying to I didn't want to go there. I want to go here. So we know that's our internal part number. Let's go to the bomb. I want to make sure these changes are now. That's an internal part number. Okay. And all we got to do is copy that, paste that in there, go here, delete. Let's get the vendor part number. That way the bomb is accurate. And then we're at all right. So we got the bill of materials here, the actual Excel bomb file updated. So there's one other thing we need to do. We need to go to the SMT level assembly. So what we should do is, so we've got version 1. We've built one. So what we're going to do is here, I'm going to duplicate. We're going to get rid of the name. We're going to do PCB02 because we're revising everything. Okay. Now, this is going to be so annoying. But this is the way you do things. All right. 1 here. Rev 2. Save inventory. Nothing there. Okay. Can I duplicate the bill of materials? New. Can I wonder if I can. If I can duplicate the bill of materials. All right. I wonder if I can. Huh. Rev 2. Oh, okay. So let's go and get rid of the USB UART chip here because that's the wrong one. And then add a line. Full speed, so the 28R. We're going to save that. 01, and then let's see if we can go to 02. Oh, all right, perfect. So it's got the 02 SMT assembly. And then we'll worry about updating the through hole, the actual assembly level, after we figured out how many additional test points and stuff that we want to add. But this at least gets us to this point to where at least if we want to build another board using that new chip, we can pull down the BOM, know what we need to order, because it was, excuse me, it's going to show that we don't have any of those USB UART chips in stock. So this is mainly the administrative stuff on this side that we need to make sure we keep on top of. That way we can keep track of all our parts and what we need to order when the time comes. So we got the new bill of materials in there. Perfect. We've got the schematics set up. So one of the things that we need to also address is a little bit of additional documentation, just because I don't want to drop anything. So here's the test plan. So one of the things we should do is also an engineering change control. So from the QMS side of things, one of the things is traceability, accountability, responsibility, and version control. You want to make sure that anything you do is documented properly. It follows all the right channels, and there's basically a chain of custody. That way, all decisions are approved. You see who approved them, when they were approved. That way, at the end of the day, you know you're shipping the latest product to your customer with all the right changes. They were properly approved by the right people. Because the larger your organization gets, the more people you have working underneath you, the easier it is for things to just get shoved over the wall, to be ignored, and processes not to be followed. So again, I used Copilot to help write a SOP, a basic SOP, just to kind of get us there. So closes, QMS, SOPs. So this is going to be an SOP 4, new file. SOP dash ECC dash 001. Helps me there. Engineering change control. .md. Oh, again, there's a lot of the QMS stuff to cover. And the point of this video was to cover all that, but there's just way too much between the building, the prototyping, the testing, and I decided to touch enough on it to give you the information, but to make separate videos dedicated to just the QMS aspects, just the quality, the project management aspects. Because I think there'll be more value in it than trying to shove everything into one video series. And those videos will be straight to YouTube. They're going to be another design, which I might do Twitch videos for the design aspect of it. Won't really cover any of the QMS stuff except when we have to. But we'll see. So. But I do want to cover enough of it here so you understand. Okay. 2026-01-10. Again, it wants to put the wrong date on. So we have the engineering change control. engineering changes in hardware, firmware, documentation, manufacturing process. So anytime an engineer has to step in, so anytime like a bench tech or a customer, anybody within, scope of your organization, especially stakeholders, which, are customers are technically stakeholders because they're the ones paying for your product. And they have a good vested interest in how well your company's doing and what you're doing. So never discount your customers. Always take their voice into consideration, the voice of the customer. And you'll learn, a lot of that comes into play with like Six Sigma and things like that. Everything just ties together in manufacturing. So anytime you have a customer problem that you have to solve, an input from, like, say, an engineer, a tech, and you can request a change but it doesn't mean, it actually gets implemented. Anybody within the organization who touches this product or has direct interactions with it or whatever has the right to request an engineering change. If they see something wrong, but it's up to the engineering and the quality department, upper management to figure out, hey, yeah, let's go and do this. But, we create a process for this change. That way everybody, follows it. So again, it covers everything: firmware, bill of materials, test processes, SOPs, manufacturing instructions. So yeah, because, of what the prompt I put in the Copilot, I'm keeping the conversation going. That way it stays consistent with how it drafts up my documentation. It's going to tie it to this particular project for any or provided. There. So yes, there can be services. There are ISO standards covering just services, just the service aspect of a business. So if you're just in sales, there's an ISO standard that covers it. 9001 is very specific to manufacturing across all industries, not just electronics, but it just, it fits because it's a manufacturing. So yes, any services that can directly interact with the customer or affect the customer, yes, you do want to do that. So you have an engineering change request. So that is a separate document. Engineering change notice. So that is another, documentation. I know it's crazy. A lot of our videos so far and streams have been documentation, but unfortunately this is the keystone to what you're doing. This is just as important, if not more important, than the products you're designing and you're wanting to put out the door. This becomes your guide. This becomes your lighthouse. This becomes what you're using to follow when you're pushing those products out the door. That way everybody's on the same page. Everybody's following, listening to the same drum. They're all doing their jobs the same way, and ensuring that the outcome is the same from batch to batch to batch. Yes, you're going to have variances due to how people are. You cannot eliminate the human factor. And I'm not asking anybody to, but you have to take into consideration, because of the human factor, you need to have constraints. And that's what proper documentation does, proper processes. So, so far that's pretty good. So there's a notice that would be a separate form that engineering would send out, basically formally informing everybody. And that would kind of get attached to any changes. So what I would prefer to do, maybe what we'll do too, is maybe draft something up in KiCad. Like a separate schematic sheet or something. Because I started doing a separate changelog sheet in Altium. And I'm going to do the same thing in Circuit Studio. Kind of like how you have a changelog for software. Why not do something like that for hardware? Now, yeah, typically your hardware won't see many revisions, but it might. And I think it's important to properly document them rather than just say, oh, I just did this. So what I might do is draft up another schematic sheet in here and just be just call it change control, and or change log, and it'll just be a log of like the ECRs. So when an ECR is generated, and then the associated ECN that would be locked to. So, control documents, major change, minor change. So in this case, what we did would be considered a major change because of we're actually affecting the function. Cosmetic change, like, minor change, that would be something like, oh, we changed the silk screen or the logo needed to be updated. That's a minor change, but you track everything. Roles and responsibilities, creates ECRs. So we might change that because, anybody can technically create engineering change request. That doesn't mean it's going to get approved. Now the ECNs and the ones actually approved, that comes from upper level. That comes from engineers. That comes from management. That comes from people with decision-making power. ECR must be initiated in any of the following, blah, blah, blah. And this is all, yep. So everything ties together within a QMS system. So like, if you have corrective actions from non-conforming materials, that may affect the board. You might have to you may have to initiate an ECR for the project. Or, anything changes. BOM changes. Always initiates an ECR. Again, it's all back to traceability and accountability. MDL 005 template. Okay. So we need to create the MDL 005 template, which I imagine, just because I want to look, the master document list. See, it already kind of factored that in for us. It already did. So we need to draft up the MDL 005 change requests and ECN. So you can use the same form as the ECN. Definitely digital would be helpful. So one of the things I've seen done is using like a PDF. So let's say you draft everything up and now you're at the point you just need approvals. Basically final approval. So one of the things I've seen done is convert that document to a PDF and then have signatures basically created in like Adobe Acrobat and actually applied to that PDF document, like a digital signature that you can self-register or actually pay to register and have an official digital signature. So I've seen various ways of doing this, or you can just have it to where you print it out, the people with power sign it, or maybe you can have some kind of e-sign policy where, something. It's really up to you how you do it, but it's kind of cool that Copilot, when I initially drafted this, it knows and it's linking everything together. So I will give it credit for that. So we'll have to draft up that MDL 005 template. I don't know if we'll get to that today. That might be something for tomorrow or another day, because I do want to get back to testing, because I want to validate the rest of the board before we get too deep into any more changes. I do know I want to do test points. Again, things are kind of going helter-skelter, and I don't want to shortchange you guys with learning anything you need to do, so maybe we will address MDL 005 tomorrow. We'll see. Maybe we can address it real quick today. I don't know. But, so here we go. Risk assessment, blah, 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 proposed. So we'll get that. Initial review. Yep. Okay, yep. Approved change. So all that can be part of the same document. And they already kind of planned that ECR and ECN would be part of the same document. All right. Now here's one of the things I was saying is would require a retesting. So any change that you make to the board that physically causes you to manufacture basically a revised product, you're gonna have to go through the test process again, and we'll retest. It's a process. Implementation, okay, so we'll have to maybe go through that, clean that up. Yep, execute verification plan. Yep, update test logs and traceability. We have to clean all that up, I think. Releasing communication is where you like send out an email, notify anybody who's relevant to that product. MDL005. So I think we're going to have a couple of different things. We're going to have like a log for this. So it might have to have a MDL005 EC, change control log to go along with the form, which is perfectly acceptable. That way you can keep track of all these different of change requests. If you're especially if you're focusing on multiple products, if like what I plan on doing is multiple products under the Magic Forge, so I may have to deal with this for multiple different projects. So I think MDL005 log, like Excel file, and then the actual template, they'll go hand in hand. So I think that's what we'll do. It's a big mess. It's a big slap in the face. But what we're going to also need to do is one of the things I've talked about is a serial number label for the boards. Zebra Designer. Let's get that popped up. So I kind of started one. So number label. I've got these little 1.5 by half. No, 1 inch by half inch labels. They're perfect size. So right now I've got it printing like you enter the project number, the product number here, and then a serial number. So what we need to do is figure out how we want to generate the serial numbers, and maybe even have a log for it. So one of the things that should do is, so that should be like a work instruction. And I'm just going to kind of create a number, product serial number creation .md. It's going to be, we're going to suss that out and actually make an official work instruction. Maybe I'll have Copilot, but I may not have Copilot help with this because, so what we want in the serial number, what do we want in the serial number to help? So maybe we want to say, okay, serial number, product serial number, numbers shall contain information. Okay, a date code. So we should have a date code as part of the serial number. A lot of companies do that. And I'm going to go to here. I don't want to bog you down with too many other things just in case. So a lot of people use the Julian format because it creates a numerical. So we want to convert calendar date to Julian date. So because it creates a numerical thing that we can take calculator and we could take the decimal 26010 and we can actually get a hex value out of it. So at the one company I worked at, we actually converted everything to hex. For one thing, you can pack more information into basically a string if it's all hex. So basically what we can do then, and then it's all convertible. And it's internally recognizable to us. The end customer does not really need to know how to interpret this. This is for us. This will be, so date code in Julian, I think it's Julien's. Julian. Okay. Julian's format. Can use this for it. Yeah. All right. Yeah, I'm really good. Yeah. We're gonna do. Copy that. Okay. So we have the Julien's date format. So we also need to try to incorporate the work order number. Well, manufacturing order number for the assembly level. Just the components. And then sequence, device sequence. My gosh, I can't type. Starting at 1. So what we can have it, then maybe what we can have it look like is date code dash MFG number dash sequence. So example, we can have so manufacture day would be 1/10/2026. This would be 26010 0. Let's go back to ARG. Manufacturing order. Operations. Wait, what? Manufacturing. Products. Ordering. I didn't realize it closed out completely. Oh, we have to go to archive. Well, crap. No. All right. Huh. Okay. So I don't even remember what the manufacturing order was for that, and that's kind of silly that I won't be able. I don't think I can go back to archive. Porting. Works. New products. New planning operations. Okay. Well, that's kind of sus that there's no manufacturing orders once we've completed them. So we will have to remember that and keep that in mind for this. Today would be today. MFG number would be, let's see, it'd probably be 3, because one was a fan, one was the SMT level, and the other one was the PCB level, or the assembly level for this guy. So we'll say it would be 3, short number, and sequence is 1. So basically what this is assuming, you want to print your labels the day that you're going to be manufacturing. And just keep all that in mind. So the serial number would be convert each entry item to X value. So serial number would be, get my calculator for that, 659A dash 3-1. Not much of a serial number, but it works for what we need it for. We could add additional things to the serial number. We could, since there's the project number, we could even use the project number. So let's try that. Clear that. But instead of the P, we'll just use 10122022501. So that would actually give us a longer hex value. And that would give us a longer serial number. So let's add that, and then we could incorporate it. So let's go back here. Let's add that. Number one, number just a numerical component. Example. Product key 1012202501. Serial number would be, I think I can Control C that. All right, there we go. So now that gives us our serial numbers. I like that better. So internally, we'd be able to decode that. We would just and take, run that through, like a hex decoder, and boom, that way we have our product number. Then our Julian date, we just hex decode it and get the Julian date, and then convert it back to manufacturing date. That way we can tie everything together. We would have to allow variances for date, a little bit of slides on each side for manufacturing, but that's fine. You can have it in the process. We can have it in here. Following information. Dates do not have to be exact. If the pauses over a shutdown, no required. No new labels are required. If labels are printed already, but build is delayed, and allowance of, let's say, a single work week of this is allowed before new labels must printed. So we'll go with that way. If a job has to be paused due to part concerns, no labels. And this is to help conserve any labels you've already printed. There's no reason to. So another thing is date, serial numbers, would also get registered in the, let's see, what was the so when we generate like a work order for this, we'll have to cover the bases on that. Basically have a serial number tracker that gets attached to that work order. Not really attached to it, but kind of tied to it. We'll create an Excel file. So again, tomorrow we'll probably be catching up on more of the documentation side. I know it's annoying. I know it's not why some are here to check out these videos, but proper documentation, proper processes, the more you establish, the better they'll be, and the better job you'll do in the long run. And this just helps you in the long run. It doesn't seem like it, but hitting hitting the ground running, sometimes is not the best approach. Sometimes the best approach is just to sit back, look at what you're doing, document, get all your ducks in a row, and then get back to it or get to it. And like I've said before, once you get your policies, your processes, your SOPs, all this laid out, and and all these ducks in an order, you won't have to rewrite these. You'll have them ready, so that'll save you a step. So again, with these videos, we're doing a little crazy. So let's say if we go to print. So here would be the product number, which would be the P1012022022501, and the serial number would be that. Okay, so I'm gonna have to shrink its size down because it's not a very big label. Text, style, 8. Apply, close, print. It's still not going to be a very big label. Close, print. All right, and that's fine. That's fine. It's just a serial number, just an identifier that you're going to stick to your board. It's a small label, but you definitely want to track. It's up to you if you want to go with bigger labels in the long run. But that's how you want to do it. Now, what's kind of cool, and before I end this video, is so one of the other reasons I like the Zebra Designer now, the Essentials version, like what I have, doesn't do this, but you can pay for the more advanced version, the advanced version, basically. And what it'll allow you to do is to feed like a spreadsheet, like an Excel file in. So just kind of. So what we've done is we had spreadsheets for a lot of things. Now, granted, I don't really much like using spreadsheets. I would rather use like a database with a web front end and have everything as automated as possible. But unless you can do that yourself, sometimes it's just easier to just use Excel files. But one of the cool things that program that Zebra Designer can do, Zebra Designer, yeah. So let's say you have an Excel sheet. So what we've done is we've made it actually into a serial number generator for us. Basically, we put the date in, it automatically creates the the Julian conversion. You can put the project number in, automatically convert it to hex. Work order number automatically gets converted to hex. And then it can basically line everything together with the sequence number, and then have a full column of individual serial numbers already lined out for that work order. And you don't have to really do much data entry. It's just basically, copying everything and dragging down, and all your serial numbers get generated. And then what you can do is use it as a data source. So when you print this, it could pull this from, see, it's not in here, but you could use an external data source like an Excel sheet and select that column, and it'll just boom, fill in. It'll just sequentially print out these labels one at a time, each one following the sequence in your Excel sheet, and it makes life so much easier. So down the road, as the business grows and I can afford to, pay for subscriptions for services like this, that's something I'll look at, because it's great. It's a great time saver, automated. And I think you can even plug in, you might be able to plug in web sources. Who knows? I don't know that much about it, because we just use Excel sheets. But, so you've got power at your hands. You've got capabilities. That's why I chose this software. That's why I got the printer that I did. Plus, they're reliable printers. I mean, I'm just going to put that out there. The Zebra engine is really reliable, and they're really easy to maintain and work on. You can at least fix them and work on them and clean them and take care of them. That's why I like them. So this is going to have to be sussed out in the long run into a more effective work instruction that will actually be tied to an SOP, basically for traceability. That's what it ties into with the ISO standard, is traceability of your products and everything else. So again, I apologize for all the documentation, but that is just as important. So tomorrow I'll be kind of touching a couple of things. I'll get the serial number generated for this board. I'll get it printed, because I got to change labels. I'll shoot that all out later, take care of all that. So I want to thank everybody for checking us out on Twitch, for following us in the stream. On YouTube, thanks for checking out the video, and I promise we'll get back to doing the bench level tests, but like I said, documentation is just as important. And well, thanks for checking us out, and have a great rest of your afternoon. See you tomorrow at 2.